Today we start our lesson on scatterplots. We are going to match the parent function with the graph that will best model the data in the following scatterplots. So let's take a look. This one, it follows a linear pattern. What you notice is it's going down from left to right. The next one is following a quadratic model. We can see it curve and follow that quadratic model. The last one follows an exponential model. Sort of notice how this flat lines a little bit here at the bottom and then it spikes up here. Okay, so my graph may be off just a tad bit, but you can see the difference between the exponential and the quadratic. Now we're going to take a look at the scatter plot here. Notice we have dots here. Take a look on the graph. We call it scatter plots because it is data that is scattered. We always try to find the line of best fit, and the line of best fit will go through those points. Some will be above, some will be below, and some will be on it. So we want to explain why choices A, B, and C are not reasonable for the data shown in the scatter plot at the left, at the right. So the slope of our first graph is 3. However, the graph in the picture has a negative slope. Check out B. The y-intercept says that it's 1, which is right here on the graph, and of course it's not going through that point. The y-intercept is much higher than 1. And the last one, how come it can't be negative 3? Well, take a look here. Negative 3, the slope is too high. If it was negative 3, we would start at a point on the graph here, and we would go down 3, 1, 2, 3, and over 1. Down 3, 1, 2, 3, and over 1. So it's too steep to be that particular equation. So a reasonable equation would be, here's the intercept, and here's the slope, and here's the equation. Negative 1 over 3x plus 8. So what we're going to do now, we're going to take this data, and this data is the AIDS cases that were reported in which particular years. We're telling you that it follows a quadratic model. That's very important. And what we're going to do is we're going to use our calculators, and we're going to click on the edit, the stat. You'll see that here at the bottom of the picture, but it's on your calculator next to the right and left keys. So you're going to hit stat, you're going to see edit, you'll hit it again, and you're going to go to L1, and in L1 you're going to put in all your X's in L1. You'll go through 1999, enter, 2000, enter. And when you're finished, you're going to go to your L2, and you're going to put in your Y values. After that, you're going to hit stat again. You're going to go over to calc, which is the second step. Because they told us it's a quadratic model, the third step, we're going to go to a quadratic regression. We're going to hit enter and take a look at what we get. First, we get a model. Y is equal to ax squared plus bx plus c. And then they tell us what to put in for A, what to put in for B, and what to put in for C. So we're going to write it out. And approximately y is equal to 345.143x squared minus this is our linear term and this is our intercept, which is our constant. What are we going to do with that? Well, we can answer other questions. This says predict the number of AIDS cases in the year 2006. Go back up here and look at your picture, year 2006. Those were our x's. So what we're going to do is we're going to plug that in for x. Everywhere we see an X, we're going to put in 2006. That's why it's good to copy this down in your note, so when you're doing any type of problems, and then you can go back and put it in parentheses. We find out there were 51,923 AIDS cases that were reported in 2006. Next question, how many were diagnosed in 1995? Well, the first thing you'll say is, oh, it's not on our chart. It's okay. We have a regression model where we can make a prediction. So 51,696 AIDS cases in that particular year. All right, now as we do these type of problems, we need to know how to clear out the data. So what you want to do is you want to go to the second, that's the button on your calculator, and then you want to go to the plus sign, because in the back of that it says memory. So second plus sign, and this is what you're going to see, and what you want to do is you want to clear all this. And so that'll take out all the X's and Y's that you just put in. So let's go ahead and do that so that we can get ready for the next question. All right, here's our second example. The data at the right shows the cooling temperatures of a freshly brewed cup of coffee after it is poured from the brewing pots into a serving cup. The brewing pot temperature is approximately 180 degrees Fahrenheit. We are going to determine an exponential regression model equation to represent the data and round to the nearest thousandths. Go ahead and put your time in L1 and your temperature in L2, and then come back. Okay, now that you have your data in the calculator, we are going to do the same thing. We're going to go to Stat, Calc. However, this time, we're going to go to exponential model, the exponential regression model. When we do that and we hit enter, they tell us how the model should be written. Y is equal to A times a B raised to the X power. So we're going to go ahead and write our equation. So we're ready to answer some additional questions. It says determine an exponential regression model that represents the equation. Voila, here it is, we've done it. Now let's take a look at the second question. When is the coffee at a temperature of 106 degrees? Temperature. Is temperature our X or our Y? Was it what we put in L1 or L2? Okay, you got it. It's our Y. So this question, we got to think about this. We want to know what X is when Y is 106. This is multiple choice, and here are your choices. So we're going to take our model and we're going to put in 106 for temperature, which is what Y is. You ever get confused, just go back and look at your chart. You know what you put in for X and Y. And here we go. What we're going to do is just check a couple. We're going to take our model. I'm going to take our model and we're going to plug in our multiple choice answer, 41 minutes. So after 41 minutes, the cup of coffee is 104.52 degrees. So let's try 40. Once we put it in 40 minutes for X, we get out 105.79. If we take a look, the question said, when is the temperature of the coffee 106 degrees? We're not going to get any closer than 105.79. What does that mean? Correct answer is 40 minutes. What is the predicted temperature of the coffee after 1 hour? Does that mean we can put in 1 for X? Or would that 1 represent 1 minute? What do you think? Okay, so 1 hour is 60 minutes. You got to think about your data that you put in. This is in minutes. So anything you do, you're going to have to convert it to minutes. We get 83.097 degrees. So that's how much it is after an hour. What do you have to say about the cup of coffee? Does it make sense that the temperature is dropping after an hour? Yeah, if it's sitting around in the room, that does make sense. All right, so next you're going to work through the examples from the first page of your notes on scatterplots and regression. Please use your calculator and finish any incomplete notes and examples on your own. Thank you for tuning in. Until next time, howdy.